Okay. Before the break, what we learned? We learned about work done by force, a pure force, spring force, gravitational force. Next, we look at energy. There are two types of energy that we focus on that you learn in your physics. You have kinetic energy. You have potential energy. What is the equation for kinetic energy? Still remember? Half mv squared. What is the potential energy equation? mgh. Now, for the coming session, we will focus on kinetic, then only come to mgh. We are now at particles. Particles, the mass is very, very small. So at this moment, for particles category or section, potential energy, we hold it first. Later, when you go into rigid body, then you will look at potential energy. So now we look at kinetic energy, which is give you half mv squared. Now, in chapter 3, we start to look at when we apply force to a body, the object will move to a new location. Right? In chapter 2, what do you learn? Chapter 2, F equal ma. And you know that force can give you acceleration. You learn in chapter 1. What is acceleration? Acceleration is the time differential of your velocity. So when you have a mass that move, there will be a velocity and acceleration. So force can generate energy that give you half mv squared. We're going to prove this hypothesis or this idea. So principle of work and energy, it does tell you that you can convert all the force as what you see on the here. This particle move in a collinear motion. So collinear motion, straight away, you should know where is the tangent, where is the normal direction, right? So this particle was subject to all the force combined, it become one resultant force. You can split your resultant force into tangent and normal direction. Okay. So in chapter 2, you know that when there's a force acting on the particles or object, it will create acceleration or motion. So F equal to ma. So you have F equal to ma in tangent direction, F equal to ma in normal direction, right? So F equal to ma in tangent direction. Why normal direction in chapter 3 we are not interested? Why? Huh? Why? It's not interested lah, but we give lower priority. Why? What is work again? What is work? Work is force multiplied by distance. What is the direction to get a positive work or negative work? It must be parallel direction. What happened to the normal direction of the force? Huh? The perpendicular. What happened to the S? Distance traveled in normal direction. What happened? Zero. It doesn't move. It still stays in that. Right? So there's one equation that you learned in chapter 1, which is A ds equal to V dv. You derive using the velocity and acceleration definition. You move the ds to the right hand side, you get A equal to V dv ds. That's what you see on the screen here. Agree? So you substitute back F equal to MAT with the AT equal to V dV ds. Then you integrate. Okay. You move this one here. You move ds to the left hand side. F ds equal to mv dv. Make sense? What is F ds? Work. Force multiplied by distance. You get work. Work on the left hand side. You integrate this one, what do you get? You get kinetic energy because m is a constant you pull out. Integrate v dv, you get v squared divided by 2. Integrate your force with the distance on the left hand side, you get work. On the right hand side, you get kinetic energy at position 2 minus kinetic energy in position 1. Makes sense? So again, recall the equation that you learned just now. You can convert your dr into cos ds. So in summary, the one that you see here, this one, is called principle of work and energy. Because inside the equation, what do you see on the left-hand side? Work. What do you see on the right-hand side? Energy. So work and energy. So when the question very specifically mentioned, for example, using your understanding in principle of work and energy, solve something. It means you cannot use F equal to ma anymore. You have to use this equation or any equation that use principle of energy. This is the first equation. Makes sense? Okay. So, yeah, every time you see question asks you principle of work on energy, means that you need to use work and energy only. In this case, we look at kinetic energy. So we simplify by writing the equation above. We half mv squared we represent as T kinetic energy. To simplify lah. Okay. So normally principle of work and energy, what does the benefit of when we use principle of work energy equation? If you want to find the velocity in a very fast way, it will help you to solve faster than chapter 1 equation and chapter 2 equation. Because inside here, you only deal with, of course, work, you need to find displacement and all this. You want to find velocity, normally you use principle of work energy, or straight away you can find velocity. Okay. So the rest is still the same. We would like to rewrite the principle of work and energy in this term because most of the time we intend to find the velocity at the second position. So we put T1 move to the left so that in our equation we have all positive value. Not positive value, but in the equation we see positive T1 plus positive work equal to kinetic energy at second station. Both also give you correct. If the question asks you to use principle of energy, you write the top equation or you write the bottom equation, also correct. Both mean the same. Okay. Now, again, we deal with work. Work when you have previous chapter or previous session, we do not talk about friction. Now we start to include friction. Take note, previous example that we see, we do not put in friction because we give you a very simplified case. We give you smooth surface and so on. But in the previous tutorial question that you see, if the friction was given, friction coefficient was given, you need to consider friction also can do work. Because friction move a certain distance, parallel also, then it makes works. Okay, so don't say, oh, okay, when you talk about work, friction, you cannot consider, right? So all the force will create work as long as it go parallel to your surface or displacement. Right? Okay, so once you understand the force, what is friction? Friction always go parallel to the motion. So in this case, it's very direct. You should be able to understand that when you draw free body diagram, the object was subject to P force, and there's a weight pointing down, and there's a dot there, means center point, and normal acting to the object. So start practicing when you draw free body diagram, start to put in center point for the object from today onwards. Because previously we don't want you to fit too many information. But now, start from today, you already learn and you're able to understand. So start to have a dot for all your free body diagram, which is a free your CG point. And we will have one, we will always have our W and N in the same direction, same axis. We will put N in the here. Or if your diagram will have too many forces, we will shift your N a little bit to the left or right. Just to give more clearer in your solution. Okay. So in this case, this is the wrong. I think it's a wrong. Okay, this one. There's one notation error there, which is half mv square, which is the kinetic before the motion happened, plus the work done. The work done is P multiplied by S. This should not be small. It should be the S here. Because P do work. P multiplied by distance is work. Then the force also. The force, the friction force also. This is should be a big S, not small s. So friction multiplied by distance traveled is, and why negative? Why friction work is negative? Is opposite. Direction is opposite with the distance traveled. So the only careless mistake is a negative sign, positive negative sign. You forget that there is a vector direction. Okay. All right, they make correction. Make correction on the slide here. The small sub s here should be the normal s, not the sub s. Okay, let's apply what we learned. Right. So you have a car sliding down 10 degrees, and you're given the mass. You start seeing mass in the following question. Slide down 10 degrees, incline, speed 6 meters per second. If the driver jam the brakes, means you press the brake. Forcing the wheel to lock, and what happened to the car will slide down. Determine how far distance traveled the tire skid on the road. Coefficient friction was given. So how do you solve? By using principle of work and energy. How do you solve? Draw free body diagram. Okay. So free body diagram. Draw the axis. I draw the floor first. Floor axis, right? So I start to do point, then distance traveled from the top to bottom. Then the weight, the degree, and be careful when you draw free body diagram. Always have the axis that go parallel to the surface, and draw one more vertical for your gravitational force. Start with mg. there's a contact surface with the 4 tires. So I've seen one student, he have 4 normal force on his free body diagram. That is wrong, right? So when you engineering dynamics question, try to group all the force in, like for example, tires act on the tires, group under tires force or normal contact, right? So you have one normal force there. It means you group all the contact surface and not put one here, right? You group all this to represent one. If not, then you make the problem a bit complex. Unless the question purposely mention front wheel and back wheel. Unless the question purposely mention front wheel, back wheel friction, then that is an indicator that your normal force have 2, one in the front, one in the back. Okay, but in your early diagnostic, you group the normal force as 1. You do 1 and then you see, the value doesn't add up, or there's a missing parameter missing. Then you break the force. Okay. What else? What are the force that missing in the free body diagram here? Friction, huh? Where is the direction of friction? Okay, go up, right? So you have all the information. So recall that we have a velocity. So the rest in this case, this statement, do you understand? The weight is displaced and do positive work. Why do positive work now? Huh? Why? Again, back to what is work? Why you get positive work? Because you split work into 2 vector, 1 point down, 1 point this direction. Where is your displacement? Go down, right? So your weight and displacement parallel, you give you positive weight, positive work. Be careful, huh? It's not necessarily negative work or positive work. You have to look at your diagram and then look at the vector direction. Yeah. In previous slides that you see, you get a negative work because of gravity. Because also the direction. Okay. Okay. We start to apply the equation. So you try to figure out this NA. In this case, you pull back a little bit from statics where in an equilibrium condition. So all the force in normal direction or this vertical direction to the surface is 0 because the car do not split off, fly off, and so on. And the tires was not pressed into this one. So NA will equal to mg cos theta equals 0. So from here you can find where is your NA. Once you find your NA, substitute here to find your friction force. Makes sense? Okay. Once you find your friction force, apply the principle of work and energy. What is the equation? Work, principle of energy. Left hand side is work, right hand side is energy. In this case, we deal with kinetic energy. So work on the left hand side, all the work done equal to kinetic energy at second position minus kinetic energy at first position. Or you can reverse, or you can rearrange. Only you on the left hand side is everything kinetic energy before plus work equal to kinetic after. So you have this equation. This will give you 2 marks in your question by writing this alone, with the summation. Then you put in all the equation. You do it one by one. kinetic energy, position 1, half mv square v1. Work, you have to be careful. Look at the free body diagram. All the force will create work. Of course, normal will not give you work lah, because it's parallel. It's 90 degree. Yeah. So positive, negative for your work done, and then kinetic energy at position 2, half mv squared. Then you can solve the question already. Right? He asks you how far? How far is the S? What is your V1? Is your V1? Here. You have M, you have G, S you don't know, sine theta you know, friction you can calculate, you already calculate already. What is the velocity at 2? 0. Only one unknown there. Okay, so the S will be 5.76 meter. Makes sense. You can do the same using second Newton law. The question will give you like two options. Maybe section A asks you to draw free body diagram. B, it will ask you to use the principle of work and energy. Then the third one, it will ask you to use second Newton law to solve the same thing. Means your answer for B was same as answer for C, but different equation. If you do F equal to ma in section B, if the question asks you use principle of work energy, then you're wrong. Although you get the answer 5.76, you won't get full mark for that one. Be specific in the equation you use. Okay, so we can solve by equation of motion. Same. F equal to ma. Focus on one specific direction. In this case, in the surface direction. All the force in surface direction, you split all W, friction force, this one also have. So you split this one, no, this one don't have. NA don't have. So you do this one, you split your weight, you split your friction, equal to ma. So your A you get in -3. What mean by negative acceleration? You slow down, you slow down. Means it agree with the logic. Because you press brake, the car slow down from 6 to 0 meter per second. Then A is a constant, use back the motion equation, the 3, pick one. This one, I pick the one that without the time, only velocity and acceleration and displacement. So here, I know that I give my direction go down positive. V square, what is a V at the 0? Initial velocity 6. AC you find already. S you want to find, this one 0. You get the same answer, 5.76. So just need to be careful on what the question want you to do. If the question asks you use principle of work energy, then you write the equation for that principle. Then you do work calculation. Work and energy calculation. Then if the question if the question doesn't mention principle of work, then normally it fall under chapter 2 question. Expect you to use F equal to ma. And start from chapter 3, you need to recall what you learned in your statics. We just now you see the use equilibrium equation here. Because sometimes you want to find the force of the normal. Normally, the approach will be using equilibrium. You freeze the object, Then see what are the force you have. You solve for equilibrium. Then you find your N. Normally, that is the approach we use. Okay. Once you find your N, normally the next step is find friction. Okay, makes sense. Okay, next one is a civil question. So you have a crane lifting a object tied with a two cable. And the force now is varying. The force is changing with the distance, 28 plus 3 distance square in kilonewton. So remember to change the kilonewton into 10 power 3 in your solution. In this case, 2.5 megagram. Remember to change into kilogram when you solve your question. Right? So this you will see megagram in your test and also final exam. So don't straight away use this value. Change to kilogram. Determine the speed of the beam when you have risen 3 meters from the floor. Also, how much time does it take to attain the height starting from rest? You know your initial velocity. First, draw free body diagram because you want to find the force that you have. Right. So of course, this example 3 is in chapter 3 question. We will use principle of work and energy. You can solve using F equal to ma also. But in this case, we try to use principal work and energy because we want to find the time it used at speed. So principal work and energy, the main benefit again, it helps you to solve velocity problem. Okay, so F, you have this force equation. So you find when you find uh, at the ground or the reference point 0, what is the force you have? What is the force you have? How you get 0? Determine. You substitute 0 here, how you get 0? What you get? 28 kilonewton. Okay. When you add when you're not 3 seconds, but when your distance is 3 meters, what is your force? Huh? Okay. We check the weight first. Weight equal to mg. So 2.5 mg. But 2.5 megagram. You want to find the weight. What is the weight value? This is megagram, not kilogram. You need to change to kilogram. Nickel, you calculate also. Don't look at your friend. Okay, you will get 24.5 kilonewton. What does it tell you? The force pull up and the weight is 24. What does it tell you? What happened to the motion? Your force pull up 28, the weight pull down is 24. What does it tell you from the motion? So there is an excess of force. Excess of force will give you ma, will give you motion. So the object is actually moving and go up positive. Okay, this is just to tell you to check whether this question got problem or not, or logic or not. This is to check whether the motion go up or go down. Okay, so free body diagram, we draw the body with the two rope there. So force pulling up from the crane, weight pulling down. Force is going up, right? I mean the displacement go up, right? Force create positive work because directions same. Weight create negative work. So in your working later, you will see positive and negative in your solution. So principle of work energy, same. Kinetic before plus work done equal to kinetic after. What is the equation for this one? Half mv square v1. What is your v1? What is your v1? From rest, 0. Although it's 0, you still need to write the kinetic equation first. What is the work done? Yeah. So what is the work equation? Force bracket what? What is the distance traveled? What is the different distance? 3. F multiplied 3. What is the work done? Minus W3. Then equal kinetic energy number 2, half mv square. What is the v2? We don't know. We want to find. So this equation you should understand, right? How many unknown you need to solve? You need to solve this one first. Because your force is in equation 28 plus 3s squared. You need to do integration and not just plug in this one in, multiply 3, then you're wrong. What happens if you substitute F equal to 28 plus 3s squared? You substitute s equal 3. What do you get? Just now, what do you get? 4? 44. 40 kilonewton. It just tell you that at 3 meter, the force is this one. But if the S is 0, you get 28 kilonewton. The force is changing. So you cannot use this 40 kilonewton multiplied by 3 meter. Then it's wrong. Because your force is in equation. You need to do integration. That's why there's the integration sign here. ds. So equation with the s, you do integration. So you do integration, what do you get? 28. You integrate f ds. You integrate 28 plus 3s square ds. What do you get? 28 become ds or 28 s plus 3 s 3, then divide 3, then you substitute the s. This one cancel. Okay, first one 0 because velocity start from rest. You do integration. Okay, I show you already. This one. Remember to put in 10 power 3 kilonewton. Without this one, you will find the wrong answer. Same with this one. Okay. The answer, you get a square root of v. Take the positive one. Why you take positive answer? Why you take positive v and not negative v? Why? Yes. Why going outward positive? Because we already defined go up is positive. And early already we find that uh, there's an imbalance of force between pull up force and weight. So the object will go up. To go up positive. So when you get V positive, that's why we use the V positive, because it's go up. The object go up. If you write negative, means the object fall down. Okay? You substitute 3 there, you get your V. How to find the time? You go to use the kinetics definition, V equal to S dt. So you move your V is the one that you find just now. This is, you move your T over left hand side. Then you integrate. Once you integrate, you find the time. Yeah, I will not go deep into calculation here. You'll get your time equal to 1.79 seconds. Makes sense. Try to understand the steps there. Okay. Example 4 is one of the famous question when it comes to final exam. So the boys slide down on the smooth water slide here from A to B. If we start from rest at A, so you're given the velocity at A, determine the speed again. If I use speed, most of the time, the next steps in your mind is actually the question asks you to use principle of work and energy, because that one is purposely to find velocity. Okay, when you reach B and a normal reaction exerted on the body at this position. So we have two free body diagram. I draw it very fast on the screen. So at A, you see the diagram here is actually a parabolic or it's a quadratic curve. It's a curve. So curve give you what? A linear motion. So there will be a normal and tangent direction. Normal tangent direction, and then collinear motion. Recall what is your acceleration. Acceleration, you have tangent direction and normal direction. Tangent direction is your v dot, dv, dt. What is the acceleration in normal? V square over rho. In this case, does the rho give you? No, so you need to find. There's an equation to find rho. Rho equal to bracket 1 plus something, 3 over 2, then something. Need to find. Normally very direct one. You look at the question, you know already what actually question want you to do. You see the question, collinear motion, don't have radius one, normally you need to find radius, because you want to find acceleration in normal direction. Okay, back to the screen here. So at point A, parabolic, so there's a tangent and normal direction. Tangent go down, normal point up because the curve shape. Then, of course, you have weight pointing down and normal force at the butt. Small b for butt. Okay. So what happened when you reach reach B? Free body diagram change already. Because at A is slanted, go down like that. But B stay like that. So you still have normal and tangent direction. Huh? So you have W and B, but just the direction is different. You have two cases, huh? One is in A, one is in B. So we look at A. Principle of work energy, still same. Kinetic energy before plus work done equal to kinetic energy at point 2. Work this one out. Okay, what is the kinetic energy at 1? 1 means A lah. 2 means B lah. Okay, so you write the equation. Half mv square for A equal to work done. If you look at here, only have 2 force, NB do not do work, right? So you only have W. Then half mv squared. You plug in the information. Before velocity A is 0, right? Then W, you know lah, mg. Distance traveled 7.5. The distance traveled 7.5. And don't confuse with the curve traveled. It's actually go down. Okay, so don't confuse with 10 meter and 7.5. This one we focus on go down. That's why your S is 7.5 and not 10. Okay. Yeah. And why we use 7.5? Again, go back to definition of work. Definition of work is force and distance must be parallel. So your force of the force for your weight is go down, right? So your displacement must be parallel, must be go down. That's why you use 7.5 and not 10. Always remind yourself what is the fundamental definition. Okay. Then you get your VB. Why we choose VB positive again and not negative? Because it's a square solution. Why we pick positive and not negative? Because it's going to the left. Then equation of motion. In this case, we use it to find at B. Just now is A. A to reach B, we use principle of energy. Then at B, we use equation of motion in normal direction because the force is only have normal. Tangent, we don't have any force. So F equal to ma in normal direction, NB minus mg, and normal direction ma. Normal direction v square over rho. Why we need to use this one? Because the question asks you to find normal reaction. So normal reaction, F equal to ma. Remember that from the previous acceleration equation, and your acceleration in normal equal to v square over rho. But here what is missing? Rho is missing. You need to find the rho. Okay. So you need to integrate this one. dy dx equal dy dx equal what? Then this one, double differentiation of y. What do you get? You get your rho. You substitute inside here, you get your rho. You solve, you get your NB. Okay. You can put your answer in the raw form, where it is 1275.3, another one decimal place, or you can put in kilonewton, 1.2 something kilonewton, 1.275. Okay, minimum 2 decimal place, maximum 3 decimal place. Example 5, I take it as your homework. But you see this one, it actually asks you block A and block B given mass, and then determine distance B traveled when it released from rest. You have the initial velocity released from rest, where the speed become 2 meters per second. He asks you to find the speed distance traveled by B when the velocity become 2 meters. You see this one? There are 2 ways of solving. F equal to ma, and principle of work and energy. Of course, we're now in chapter 3, we use principle and energy. And you see pulley system, recall pulley system principle, pulley system solution. Check logic first. 100 gram, 10 gram. This one you release, what happened to A? A go up. This one, be careful on the datum. SB go down, positive. SA go down, positive. When you see pulley system, what is the general idea? You focus on the total length, calculate the total length, equal to SB, 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 SA. What is the purpose of finding the total length? You want to find the relationship between A and B. You want to find the velocity and A and B, and also acceleration of A and B. You see this pulley system, straight away do the total length equation, differentiate. Okay. Then you back to the either F equal to ma or principle of energy or work. Okay. Draw the free body diagram, what you see on the screen there. Then you pull the principle of work and energy. In this case, what is different? You have two body. Two body means you have two set of kinetic energy, two set of work, two set of work kinetic energy after. You combine in one equation. The two body, remember, you have two different body. Each body give you kinetic energy. And then just a remark. This is single rod. When it comes to final, it might be have two rope. One rope stop here, maybe stop here. I connect one more rope from here. I connect this rope here and not continue from here. So you have two total length. Okay. You do all the equation. You cancel here and there, and you get answer. So this is the pulley solution. Okay. From there, put inside there, you do homework, you're able to find distance traveled by B. Going down, you get positive because the datum positive go down. Okay. So next lecture, we look at power. Okay.
Can you go to the last chapter?
Okay, I stop the recording first.